Okay, here's the thing. Number 10, Hawking radiation. A black hole should be perfectly dark. No glow, no signal, no trace. But zoom in close enough, and reality starts to flicker. Empty space isn't empty. It's unstable, restless. Pairs of particles appear, out of nothing, then vanish, over and over, everywhere, all the time. Normally, they destroy each other instantly. No escape, no evidence. But near a black hole, that balance breaks. Hard. Gravity stretches space-time, like it's being torn apart. And suddenly, those particle pairs separate. One falls in, the other gets away. And from far away, it looks like radiation. A faint glow. From something that should emit nothing. Impossible, but real. This is Hawking radiation, and it changes everything. Because that escaping particle carries energy, real energy, which means something pays the cost. The black hole. It loses mass. Slowly, quietly, but constantly. A black hole can shrink, it can fade, it can disappear. Not quickly, not violently, but inevitably. For a black hole the mass of our sun, this would take longer than 10 to the power of 67 years, longer than anything we can imagine, but still finite, which means something deeper is broken, because black holes weren't supposed to die. They weren't supposed to give anything back. And yet, they leak. So now the question changes. It's no longer, can anything escape? It's this. What else is already getting out? And the next answer doesn't even try to escape. It just ignores the rules. Number 9. Quantum tunneling. Barriers are supposed to stop things. That's the idea. That's the rule. If you don't have enough energy, you don't get through. End of story. But quantum physics disagrees quietly, completely. Particles don't behave like objects. They behave like probabilities, blurred, spread out, uncertain. So sometimes they don't go over the barrier, they don't break it, they don't go around it, they just appear on the other side. No path, no crossing, no warning. It's called quantum tunneling, and it shouldn't make sense. Now take that idea and bring it to a black hole. The event horizon is supposed to be absolute. A perfect boundary, cross it, and you're gone. Forever. But quantum rules don't respect boundaries. Not even this one. At incredibly small scales, there's always a tiny chance. A fluctuation, a leak, a particle inside, can be described as partly outside. And sometimes, that's enough. Enough to exist beyond the horizon. Enough to escape. No force, no explosion, just probability. Winning. This isn't dramatic, it's subtle, but it's relentless. Given enough time, even impossible things happen. And here's the twist. This might not just apply to particles. If information is encoded in those quantum states, then pieces of it could tunnel too. Meaning something that fell in might not be completely lost, not erased, just smeared, across probabilities, across the edge. So the black hole isn't perfectly sealed. Not really, it's porous, at the smallest level. And if that's true, then the boundary isn't a wall, it's a suggestion. And what comes next? Doesn't leak, it explodes outward. Number 8. Relativistic jets. Matter falls in. That's how it starts. Gas, dust, entire stars, pulled inward, no escape. But something strange happens. Before the fall is complete, it doesn't go quietly, it doesn't disappear cleanly, it fights. As matter spirals inward, it forms a disk. Hot, bright, violent. Friction builds, temperatures rise, millions of degrees, and then something breaks symmetry. Not everything goes in. Some of it gets redirected along the poles, straight out, at nearly the speed of light. Relativistic jets, beams of energy, so powerful, they punch through entire galaxies. This shouldn't happen. Black hole is supposed to trap everything, not launch it, but the rotation changes things. The black hole spins, dragging space-time with it, twisting everything nearby. Magnetic fields get caught in that spin, wound tighter, stronger, until they snap. And when they do, they don't collapse inward. They explode outward, launching matter and energy across millions of light years, escaping from something designed to prevent escape. And here's the deeper problem. The energy in those jets doesn't come from nowhere. It comes from the black hole itself. Its rotation, its stored energy, being drained. So the black hole isn't just consuming, it's losing, bleeding energy into the universe, violently. And if energy can escape like this, in massive, visible streams, then what else is being pushed out that we can't see? Because the next thing doesn't shine. It distorts reality itself. Number 7, accretion disk radiation. Nothing crosses the edge quietly, not even close. Before anything reaches the horizon, it slows down, spirals, stretches, and then it ignites. The space around a black hole isn't dark. It's one of the brightest places in the universe. Matter piles up into a spinning disk. Faster, hotter, denser. Until friction tears it apart, temperatures climb. Into the millions, sometimes billions. Atoms break, electrons rip free, and everything starts to glow. Blinding, violent, relentless. X-rays, gamma rays, radiation blasting outward in all directions, escaping before the final fall. This is the accretion disk. And it shines brighter than entire galaxies. So the black hole itself may be invisible, but its surroundings scream. And here's the twist. That light never actually comes from inside. It comes from the last moment before crossing. The last chance to exist on this side. After that, nothing. So what we're seeing isn't escape from the black hole. It's escape from the edge. A boundary moment, frozen between two realities. And once it crosses, it's gone. Or at least, that's what we think. Because if radiation can escape right up to the limit, then how sharp is that limit? Is the horizon truly a line? Or something messier? Because the next thing doesn't emit light. It erupts from something invisible. Number 6, magnetic field eruptions. You can't see them, but they're there. Everywhere. Magnetic fields. Invisible lines of force. Threading through space. Normally, they're quiet, subtle, controlled. Near a black hole, they go insane. As matter spirals inward, it drags magnetic fields with it, twisting them, stretching them, tighter and tighter, until they snap violently. This is magnetic reconnection, and it's explosive. Energy stored in those fields is released in an instant. Particles accelerate, radiation bursts outward, escaping from the edge of no escape, and it happens fast, blindingly fast, faster than anything falling inward. So instead of everything collapsing, some energy fights back, breaks free, launched outward, before gravity can win. This shouldn't happen, because the closer you get, the stronger gravity becomes. But here, something else takes over. Energy stored in the fields becomes stronger than the fall. For a moment, long enough to escape. And here's the deeper twist. These eruptions don't just release energy, they reshape the entire region. They control the jets, they power the radiation, they decide what gets out. So the black hole isn't acting alone, its environment matters. A chaotic system, where escape is still possible, even near the edge. Which raises a problem. If invisible fields can store and release energy like this, what happens when space-time itself starts storing energy? Because the next thing doesn't explode outward, it ripples through reality. Number 5, frame-dragging ejections. Space-time isn't fixed, it moves, not metaphorically, literally, around a rotating black hole. Space itself starts to twist, dragged along, like water around a whirlpool. This is frame dragging, and it's not gentle. The closer you get, the faster space-time spins, until motion becomes mandatory. You can't stay still. You can't resist. Everything is forced to rotate. This region has a name, the ergosphere, and inside it, something strange happens. Energy can be stolen not from matter, from the black hole itself, through a process called the Penrose mechanism. A particle falls in, splits apart. One piece gets captured, the other escapes with more energy than it started with. Impossible, but allowed, because the black hole is spinning, and that rotation can be drained, converted, redirected, ejected outward. So instead of only consuming, the black hole can give energy back, not by choice, but by geometry, by the structure of space-time itself. And here's the deeper implication. If energy can escape this way, then the boundary of no escape is already broken. Not at the horizon, but just outside it, where space-time twists, too violently to stay contained. So escape doesn't require breaking physics. It uses it, and that's the unsettling part. Because the next thing doesn't carry energy, it carries information about motion itself, and it doesn't travel through space. It shakes space. Number 4, gravitational waves. You don't see them, you don't hear them, but they pass through you, right now. Ripples in space-time, not light, not particles. Distortions, stretching space, compressing it, born from violence, the most extreme events in the universe. And nothing is more violent than two black holes colliding. They spiral closer, faster, closer, until they merge. And in that moment, something escapes. Not matter, not light, motion itself, the energy of their orbit, released as waves. Gravitational waves. They travel outward, at the speed of light, across galaxies, across the universe. Unstoppable. Even black holes can't hold them in, because they're not inside. They're the change, in space-time itself. And here's the twist. These waves carry information about mass, about spin, about the final moments, before the merge, encoded in the pattern of the ripple. So even when everything seems trapped, the history of what happened still gets out. Not as objects, but as distortions. And we've detected them, tiny shifts, smaller than an atom, yet undeniable, which means something profound. Black holes don't just consume events, they broadcast them across the universe. In a language we're only beginning to understand. And if motion can escape, if energy can escape, if even the shape of space-time can escape, then what about something even more fundamental? Because the next thing doesn't travel outward. From our perspective, it never goes in. Number 3, time from your perspective. From far away, nothing ever falls in. That sounds wrong. It is, and it isn't. Watch an object approach, a black hole. It accelerates, faster, closer, but then something strange happens. It slows down, not in its own frame, in yours. Its clock stretches. Time itself starts to fail. Seconds become minutes. Minutes become hours. Then, almost nothing. It freezes, right at the edge, the event horizon. You never see it cross. Never. It fades. Reader, dimmer, until it disappears completely. Not because it fell in, because its light can no longer reach you. So from your perspective, it never enters. It just hangs there, forever, a frozen ghost, on the boundary. And here's the twist. From its perspective, it crosses instantly. No hesitation, no drama. Two realities, both correct, completely incompatible. So, did it escape? In your timeline, yes. It never truly leaves your universe. It never completes the fall. Time itself prevents closure, and that breaks something deep. Because falling in is no longer absolute. It depends on who's watching, which means escape might not be physical. It might be perspectival, a loophole in time. If time can trap events outside the horizon, then what about the information those events carry? Because the next thing might never be lost at all. Number 2, information paradox leakage. Nothing should survive the fall. That's the rule. Cross the horizon, and everything about you is gone. Your structure, your state, your history, erased. But physics refuses to accept that, because information can't be destroyed. Not in quantum mechanics. Not ever. So now we have a problem. Black holes say, it's gone. Quantum physics says, it isn't. Both can't be right, so something has to give. And what gives is our understanding of the horizon itself. Because maybe information doesn't go inside. Maybe it stays, encoded on the surface, stretched, smeared, across the event horizon, like a hologram. This is the holographic principle. Everything that falls in is somehow written onto the boundary, not lost, not destroyed, just transformed. And here's the unsettling part. If Hawking radiation carries subtle correlations, tiny imprints, then information might slowly leak back out, bit by bit, over unimaginable time, hidden, scrambled, but not gone. So the black hole isn't a vault, it's a processor, taking in information, encoding it, and eventually releasing fragments back into the universe, distorted, unrecognizable, but still there. Which means nothing truly disappears, not even inside a black hole. And if that's true, then the horizon isn't the end, it's an interface, a boundary between realities and what lies beyond it. Might not be destruction, it might be a doorway. Because the final idea pushes this to the extreme, not escape from a black hole, but escape into something else. Number 1, white hole hypothesis. What if nothing ever really gets trapped? What if everything that falls in comes out somewhere else? A white hole, the theoretical opposite of a black hole. Instead of pulling things in, it only pushes things out, relentlessly. No entry, no return, only escape. It sounds impossible, but the equations allow it. Reverse the direction of time in a black hole solution, and you get this: a region where matter can't go in, only out, exploding, constantly ejecting whatever it contains. And here's the unsettling idea. What if a black hole and a white hole are connected, not here, but somewhere else, through space-time itself, a tunnel, a bridge, a wormhole, something falls into a black hole and emerges from a white hole, not destroyed, just displaced, across the universe or beyond it. No one has ever seen one. No evidence, no confirmation, but no rule forbids it. And some theories suggest that black holes might evolve into white holes over unimaginable time, releasing everything they ever consumed, all at once, or slowly. We don't know. And that's the point. Because at this level, escape stops meaning anything we recognize. It's no longer about leaving. It's about transformation. About where reality continues, when our understanding ends. And if something can come out somewhere else, then falling into a black hole might not be the end, just the part we can't see. We thought black holes were prisons, perfect, silent, final. But they leak, they twist, they broadcast, they remember, and maybe they connect. So escape isn't impossible, it's just unfamiliar. Because at the edge of a black hole, reality doesn't break. It changes.